Hi, I'm Jessica, and today I'm going to be talking about a chemical demonstration I like to call money to burn. And chemist Dr. Bassam Shakashiri, here he is actually going to be showing us the demo. He's the president of the American Chemical Society and is performing this demo right here at MIT. Let's see if he has some money to burn.
What I'm going to do now is going to reach in here, I'm going to take a dollar bill, and I'm going to put it in the flame just like that. Was that too fast? What we always do in science is repeat the experiment. So I take out what looks like a dollar bill, but it's not a real dollar bill. I bring it close to the flame. It disappears into thin air. It looks like magic, right? I love magic. Magic is engaging, but not informative.
How is that dollar bill burning up so quickly? Well, it's actually not a dollar bill. It's called flash paper. And it's paper that has been treated with chemicals to make it burn quickly and leave no ashes. Now, flash paper has been nitrated. Practically, what that means is that you soak the paper in a mixture of concentrated nitric and sulfuric acids. The cellulose in the paper then reacts with the acid to produce nitrated cellulose and water. The reaction is this. So our nitric acid here mixes with the cellulose. Now this is actually just one unit in the big polymer that is cellulose. It's got lots of little units of C6H10O5. So in this equation, I'm only writing one unit. And that's creating nitrated cellulose and water. Now the nitro group, the NO2, is the reactive group, and it can be very reactive depending on the molecule that it's in. You've no doubt heard of nitroglycerin, which looks like this. It's an explosive liquid, or TNT, which actually stands for trinitrotoluene. It looks like this. So all of these molecules have nitro groups in them. And it's the nitro, or NO2 groups, that make these molecules explosive. Now let's watch what happens when Dr. Shakashiri tries this again, but this time with a real dollar bill.
I'd like someone in the audience to let me borrow from them a real $1 bill. Is there someone in the audience who would trust me with a real $1 bill? Or a $5 bill? Steve, how about a $20 bill, huh? You got a $20 bill? Okay, here's $1 bill. It's a real $1 bill. You know what I'm going to do with it, don't you? So, well, I have a jar right here, and I have in this jar, what does it look like? I have a liquid. What does it look like? Looks like water. The way we describe this liquid is to say it's a clear and colorless liquid, which is what water is. Okay? So I'm going to take this liquid, and so I want everybody to see the jar right here. Get this out of the way. I'm going to take the dollar bill. I'm going to soak it in this clear and colorless liquid, which looks like water, and I'm going to fish it out using those tongs. You see it's dripping like any wet object would, right? And then I'm going to take it to the flame. Take a good look at it now, Judy. It's maybe the last time you see it. So here is the dollar bill on fire. Or is it? But you did see a flame, didn't you? So now I ask you, can this liquid be water? You know from experience that water does not burn under these conditions, right? So I will tell you what's in this jar. This clear and colorless liquid is a mixture of rubbing alcohol and water, isopropyl alcohol and water. You know also from experience that when you burn alcohol, what color flame do you see? It's kind of bluish, right? Do you remember what color flame you saw here? It was a little yellowish, right? Right? That's because we also added a little bit of sodium chloride in there. The eye is more sensitive to the yellow color than it is to the blue color. So we added the sodium chloride to enhance the visibility of what's going on.
All right, so what happened there? Dr. Shakashiri soaked the money in a solution of water, rubbing alcohol, and a little bit of table salt. When he puts the money in the flame, the alcohol burns, producing heat and light, energy, and carbon dioxide and water.
The reaction is this.
There's our alcohol reacting with oxygen, producing carbon dioxide, water, and energy. So why doesn't the bill burn?
If you have a beaker of alcohol and light it on fire, it's just that very top layer of alcohol and the gas above it that burns. The rest of the alcohol in the beaker does not.
So that's what's happening with our dollar bill. Let's draw a dollar bill right here. So the alcohol, ROH could be any alcohol, is evaporating off the bill, turning into a gas and burning. So those are the flames that you see. But remember that the solution is 50% water. The water is evaporating much less quickly than the alcohol, staying in the bill and preventing the paper from burning. So that's one way to hold on to your cash. Hope you enjoyed Money to Burn, and I'll see you next time.